any game to play, like for any game to play, we should have a playground or platform. So similarly for statistics, we have various software to play with data. And these are called statistical software. So these are some statistical software you can see here. So it is most popular. This is most popular Excel, Microsoft Excel. Okay, it is a most popular statistical software. We can do any statistics with the help of this Microsoft Excel. This is SPSS. It is very user friendly, very easy. This is GraphPad Prism. This is MedCalc, you can see here. This is Stata software. It is similar to SPSS. And this is R software. It is free of cost. R Studio, R software. This is SAS statistical software. This is Jamovi. You can see here. This is icon Jamovi. And today we will have demonstration on Jamovi. How to use Jamovi for descriptive or inferential statistics. And this is JASP. It is new. Jamovi and this JASP are new software, and there are many more software. So these statistical software, we can do analysis. At least in one, we should have mastery. There is no need for all, we should have mastery, at least for one. Jamovi and SPSS is similar. Okay, SPSS is paid software and Jamovi is free software. R is free software, but it is very difficult to learn. R, and this is a SAS, Prisma, GraphPad, Prisma, MedCalc, and Stata. These are all paid software. Because Jamovi is free, so we will do hands-on on Jamovi. It's very easy. So what are the data? Anything in this universe and beyond this universe, anything that is data. Number of students, this is data. Height, weight, data. Number of male, number of female, data. Whatever. I have 10 rupees, I have 50 rupees, that is data. How many stars in this sky, this is data. This is beyond this universe, okay? And what is statistics? It is play with data. So anything that is data and statistics, that is play with data. And today we will play. And it is understand the data, talk with data, listen to data, and play with data. That is statistics. If we understand data, then we can do with data what we have to do. So we have to talk, we have to listen, and then we have to play. If we understand that, then we can get some results. So that is statistics. It is most popular slide. Variable or data. Sometimes variable and data, they are using the interchangeably. We are using variable data, okay? So these are both are similar, you can say. We can use data word, there is no problem. But we have to understand that basically variable or data is of two types. Number one is quantitative data, numerical data. And number two is qualitative data. You have to remember, or I hope that you have, and I think previous speaker explained very well about this. Okay. If not, then you have to understand this. Quantitative data means numerical data, numbers. Qualitative data means they are telling about quality, good, soft, black, male, female, something like quality, characteristics they are telling. Okay, description they are telling. These are called qualitative data, categorical data. Okay, that is, these are categorical data, male, female, religion, Hindu, Muslim, Sikh, Isai, something. That is a qualitative data. Okay. So when we talk about quantitative data, numerical data, it is further divided into continuous data and discrete data. Discrete means whole number. We cannot give any fraction or decimal in this. If we can give any fraction and decimal, it is called continuous data. You have to understand this thing. This slide you have to understand. It is most popular slide and you have to understand this slide, this concept. So continuous means which numerical, quantitative, which have fraction or decimal. And usually we are measuring this. For example, height, weight, these are coming in decimals. BMI, age, systolic blood pressure, diastolic blood pressure, HB, hemoglobin, electrolytes, exam score, anxiety score, whatever, income. These are all continuous data. We can present these in fractions. When we talk about discrete data is a type of quantitative numerical data. But in whole number, we cannot give any decimals. How? Number of family members. If there is one children and 3 adults, we cannot say 3.5. We have to say how many family members? 4 family members. We cannot give any decimals. For example, pulse rate, number of chairs, number of students, heart rate, and you have to think about this. These are called discrete, whole number. So discrete and continuous, it is a type of quantitative. And I have told about qualitative, like male and female, religion, color, white, black, behavior, personality, introverted, extroverted, day or night, alive and dead, good and bad. These are presenting quality of. So these are qualitative data or categorical data. Male and female, alive and dead, good and bad. These are divided into 2 categories. So those qualitative or categorical data, which we can divide it only 2 categories, it is called binary data. So you have to remember binary, male or female, yes and no, binary, good and bad, binary, alive, dead, binary, day, night, binary. But if you divide into 3, day, evening, night, it is not binary. It is also categorical qualitative, but it is not binary. But if you divide it into 2 categories, day and night, that is called binary. Okay, so you have to understand this. So if you have any question, you can ask. So now type of statistics. So it's mainly 2 types: descriptive statistics and inferential statistics. So first you have to remember this slide, then we can move this to this. So basically statistics is of 2 types: descriptive statistics and inferential statistics. Today we will discuss about descriptive statistics. Okay. Tomorrow we will discuss about inferential statistics. Type of test, t-test, chi-square test. Have you heard? I hope that these names. These are in inferential statistics. Okay. So in descriptive statistics, we summarize the data. And it is of 2 types, quantitative and categorical. So when we talk about quantitative, as I told that data is 2 types, quantitative and categorical. So if it's quantitative type of data, so we have to calculate or measure central tendency of that variable or data and dispersion. So central tendency, we calculate mean, median. For dispersion, we calculate standard deviation, we calculate interquartile range, we calculate range minimum and maximum. Sometimes we calculate standard error also. So these are these are descriptive statistics of a quantitative type of data, mean, median. Okay. And then SD, standard deviation, interquartile range, standard error. These are descriptive statistics for quantitative type of the data. And if there is a categorical or qualitative, then we have to calculate frequency, proportion, percentage, and mode. So for mode is for categorical data mainly. Okay. When we talk about inferential statistics, okay, so we have to generalize for population from this sample. We have sample, what we are doing in study or research study. We have to collect some sample, and from these samples, we have to like give inference to to our general population from where we took that sample. And for this, we have to calculate estimation. And for estimation, we have to calculate a confidence interval, and mainly 95% confidence interval. And number two, hypothesis testing. Okay, for different type of statistical test, we do this hypothesis testing, null hypothesis, alternate hypothesis. So we use t-test and chi-square test and ANOVA test, and sometimes regression, correlation, something. So these are called inferential statistics. And descriptive statistics, we will do only mean, median, mode, interquartile range, frequency, percentage, proportion. That is. So this is another like type of variable or data, and we have, like I have told in the previous slide, variable or data is two types, that is a qualitative or categorical, quantitative and numerical. Okay, so quantitative and numerical further divided into discrete and continuous. You have to remember. And qualitative or categorical data further divided into nominal and ordinal. Okay, and sometimes is ordinal is also for quantitative. Okay, sometimes we are using like ordinal for also for quantitative, numerical. For example, pan scale. Okay, pan scale 0 to 10, that is an ordinal number. Okay, then this is also a quantitative, numerical. Okay, so in qualitative, this is or categorical, there is a nominal. This is nominal, ordinal, interval, and ratio, something like that. Okay, so that is nominal, ordinal, interval, and ratio. That is a level of measurement. Okay, we will do further in slides. But you have to understand about nominal. We cannot order that variable. We cannot order that data. So that is nominal. For example, male and female. We cannot order male and female. Like male is superior than females. We cannot say. If both are equal, that is a nominal. We can give only name, male and female. For example, religion. Hindu, Muslim, Sikh, Isai. We cannot order. Like we cannot say like Sikh is superior or Hindu is superior compared to Muslim and Christian, something like that. We cannot order. We just can give name. So that is called nominal. When we talk about ordinal, it means we can give rank, order. For example, disease severity. That is mild, moderate, severe. If we can give order like level of pains, no pain, mild pain, moderate pain, and severe pain, that is ordinal type. But if we are measuring pain in numerical scale, 0 to 10, that is coming in a quantitative. It is order 0, 1, 2, 3, up to 10. That is like ordinal nature, but it is of quantitative type. So you have to just remember this. Discrete and continuous, we have already told you that what is discrete and what is continuous. So you have to remember and you have to tell me that like you have to see, this is a like our data sheet, and you have to tell me or you have to remember this. This is given serial number, okay, in A column, and this is B column, name of the patient or participant or subject. So if I ask you which type of this variable, it is first quantitative or qualitative, you have to say which is, it is quantitative or qualitative. And if it is qualitative, then which type of nominal or ordinal? So you have to remember. We can, and you have to that this is a name, not a numerical. So it is a qualitative type of, and these are the name we cannot like order this. Okay, we cannot order. So it is a nominal type of. When we talk about age, you can see here age. So which is it is a nominal, it is qualitative type of, or it is quantitative type of. So you have to think about this. And when we see previous slide, okay, here, where is age? Age is in quantitative type. It is a discrete or continuous. You have to remember this. So age is coming continuous type of data. Okay, you have to remember age is coming continuous type of data, not discrete. When we talk about sex or gender or socioeconomic status, okay, when we talk about gender or sex, so which type of nominal, ordinal, interval, or like discrete and continuous? So you have to, it is a qualitative or it is a quantitative. So we know that it is a qualitative type of. In qualitative, it is a nominal. And it is male if it is has male or female, because it is like related to delivery, okay, birth, weight, delivery. So I think it's like in this study only females were recruited. Okay, so you have to remember. Then this is live child. Okay, so live child is a type of numerical, quantitative. So it is a quantitative, number one. Number two, it is a discrete or continuous, because this is a child and okay, number of childs, live child. So it is a discrete type of. We cannot like give any decimal to this. So we have to remember. Okay. So and we see birth weight. So birth weight is number one, qualitative or quantitative. Okay, so these are the numbers, numerical, so it is in quantitative. In quantitative, it is a discrete or continuous, because it has birth weight. Weight can have decimals, so it is a continuous type of. So we have to remember this. Now, we have to do this for descriptive statistics. As I told you earlier that we have to we have to calculate mean and median for measures of central tendency. Okay, we have to calculate standard deviation, standard error, interquartile range, minimum, maximum for measures of dispersion. And for this, for which we have to calculate mean, for which we have to calculate median, for which we have to calculate standard deviation, for which we have to calculate interquartile range. It depends on normal or distribution of that particular variable. If it is a normal distribution, we should calculate mean and standard deviation. If it is skewed, then we have to calculate, or we should calculate median and interquartile range. So for normal distribution, we do only for continuous variable, only for mainly continuous variable. For discrete means normal distribution we can do only for quantitative type of variable, not for qualitative type of variable. Okay, for male or female we cannot do normal distribution. There is no use of normal distribution. But for age we can do normal distribution. We should do normal distribution if that variable is normally distributed. Then we should use mean and standard deviation. If it is not normal distribution, we should go for median and interquartile range. Minimum and maximum we can go for both. Standard error we can go for only for if it is a normally distributed. So for normal distribution, we use some test. We do some graphical presentation. So that is called histogram, QQ plot, that is a quantile plot, and some statistics like skewness and kurtosis. For normal distribution, we do some test. Okay, and that is a Shapiro-Wilk test, and Kolmogorov-Smirnov test. So I recommend Shapiro-Wilk test. How to do? I will show you. So this is for quantitative type of variable, and this is for categorical or qualitative type of variable. And for qualitative type of variable, we will do proportion, frequency, and percentage. So this is example, like total number of participants were 100, and out of 100, 25 were female. So what is proportion of this? This is 25%. So for qualitative type of data or variable, we can give like in a percentage, frequency and a percentage. Number two, number of individual subjects, participant, total 500, and number of deaths, 50 out of 400, sorry, 400, 50 out of 400. So proportion of death, that is a 50 divided by 400, that is a 12.5%. So for qualitative or categorical data, we should do for proportion and frequency and proportion. And for quantitative, we have to do mean, median, SD, interquartile range, something, minimum, maximum, okay? So this is about normalcy test, okay? So we will, okay, understand this. If we will perform this Kolmogorov or Shapiro-Wilk test, we will do, no issue. So when we get, and if the normalcy test, that is a Kolmogorov-Smirnov or Shapiro-Wilk test, p-value is less than the predefined significance level, usually we are taking less than 0.05. So if p-value is less than 0.05, we can reject the null hypothesis and conclude the data are not normally distributed. So you have to remember, if we are getting p-value in Shapiro-Wilk or in Kolmogorov-Smirnov test less than 0.05, then we can say that particular variable is not normally distributed. And if we are getting p-value greater than this, then we cannot reject the null hypothesis, and then we can conclude that this variable is normally distributed, and this variable is normally distributed, we can go for mean and standard deviation. If it is not normal distributed, we should go for median and interquartile range. But note that a small deviation from normality can produce a statistically significant p-value when the sample size is too large, okay? And conversely, its opposite, it can be impossible to detect non-normality with a small sample. So if there is a sample size is large enough, if sample size is small enough, like less than 5, and large enough, for example, greater than 100, 200 something, so there is a small deviation, the normalcy violated. So for this, we should always examine the normal plots like histogram and QQ plot and use our judgment, okay, rather than relying only and only on the hypothesis test. That is a Kolmogorov and Shapiro-Wilk test, okay? So we have to see this Shapiro-Wilk test first, then we can use histogram and QQ plot, and then we can generalize our finding this variable is normally distributed or not normally. So we have to remember this. So what is normal QQ plot? A normal probability plot or quantile or QQ plot shows the distribution of the data or quantitative variable, we have to remember, against the expected normal distribution. For normally distributed data, observations should lie approximately on a straight line. I will show this. I will show you. Okay. If the data is not normal, the point form a curve that deviates markedly from a straight line. I will show you. Possible outliers are points at the end of the line. I will show you this QQ plot, how to make it and how to interpret it. Okay. So this is QQ plot. You can see here. Okay. So this is line of normally distribution, and these are the observation. Okay. And you can see here most of the observations are near to or on the line. Okay. You can see near to line, close to line. Okay. It means it is a normally distributed. This variable is a normally distributed. Maybe it is a age variable. Okay, this is 0, 5, 10, 15, 20. This is so for example, it is a age in years. So this is a normally distributed. Age is a normally distributed. When we see about skewness, okay, then skewness and kurtosis. So mainly is skewness. So we have to look at tail of this distribution. So you can see here, this is normally distributed. Okay. But when we see this and this, so this tail is in right side. So it is called right-sided skewed or positive skewed. Here, this tail is in left side. So it is called left-sided skewed, or that is a negative skewed. So generally for normal distribution, this picture should come. If right and left is coming, it means our data is not normally distributed. And our skewness value should be equal to or close to 0. Then we can say it is a normally distributed. Okay. Then this is normally distribution. You can see here it is a age variable. This is a frequency 0, 5, 10, 15, 20. How many percentage of the participants having this much age? And when we see or check this distribution or histogram this age, it is coming approximately normally distributed. Okay. Checking normalcy, as I have told you that methods we should go for histogram and QQ plot. For descriptive statistics, we should go for skewness and kurtosis. Okay, and skewness and kurtosis rule of thumb is the value should be like for skewness should be +2 to -2, and for kurtosis it should be +3, something like that. Okay, for kurtosis, normal distribution kurtosis +3. For statistics, we can use Shapiro-Wilk test or Kolmogorov-Smirnov test. So interpretation, if p-value is less than 0.05, non-normal distribution. P-value of this is Shapiro-Wilk test or Kolmogorov-Smirnov test. Okay. And p-value is greater than 0.05, equal to and greater than, we can say it is a normally distributed. So you have to remember this. Okay. So let's have fun. So I have sent data to you, then you can open. And if you have any question, you can ask me right now. Then we can move further. Okay, you can ask me. You can send on chat. There is no problem. I have sent you data. So this is my data. You can see here. This is data sheet. This is Excel data sheet. You can see this is serial number. This is group intervention and control. This is age. I have given coded to intervention group 1 and 2. I have coded. Okay. This is age. This is sex. And this is sex code. Okay. So you should give coding to these all qualitative or categorical variable. Okay. So here 2 is female and 1 is male. This is occupation in 4 categories. This is income, height, weight. This is diabetes status 0, no diabetes, 1 diabetes, you can see in this data. Smoking, 1 means smoker, 0 means no smoking. Family history of diabetes, 1 is yes, 2 is no. Okay, you should give 0 to no. Okay, so pen score, this is systolic BP pre, this is systolic BP after intervention, this is anxiety pre-intervention, this is anxiety post-intervention. And for this I have make a code book. You can see here, you can see this I have given, like for example in group control I have given 2 number, and for intervention I have given 1 number. You can see here, you can see here. Okay, for control I have given 2, for intervention I have given 1. Okay, and these are the like values. You can see this is, it is called coding. In occupation there is 1 is business, 2 is government, 3 is private, and 4 is others. So you can see here. Okay, then you can see this is a pre-SBP, this is a systolic blood pressure in mm of Hg before treatment, after treatment, anxiety score before treatment, anxiety score after treatment. So these are the variable short name, and there is a description. Okay, you can make a code book, and this is our data sheet, clean data sheet. You can see it's a clean data sheet. And in data sheet, in our first row, our variable name should be, and from second row our data should be. You have to remember this. In first row our variable name, okay, and from row 2 our data entry should be start. You can see here. Okay, so this is total how many like a patient. There is a total 200, 100 in intervention and 100 in the control group. Okay, so now I will use Jamavi software. So you can open Jamavi. So I can open Jamavi. There is no problem. Jamavi. This is Jamavi software. I will open. Yes. I think Jamavi. Jamavi will not. 1 minute. It's opening. It's opening. Okay, I have to wait for some time. Okay. What is it? Meanwhile, you can open Jamavi. There are some. Okay. So this is Jamavi. I want to. Okay. Yes, I can put it here. No issue. Okay. Yes, I think I should. So this is Jamavi software. It is free of cost, and you can do majority of the statistical analysis in this software. It is similar to SPSS. Okay. So this is Jamavi. You can see here. This is in left upper corner. You can see here. This is new file, open file, import, save as, export, something like that. Then this is a variables. Okay. This is data. This is analysis. It is most famous. This is edit button. Okay. We will do one by one. So what we have to do, we have to first import that Excel file into Jamavi. So for this, what we have to do, please look at here. Here there is a left upper corner, you can see 3 lines. Okay, you have to click this. Then you have to click open. Okay, then click open. This window will open here. You can see, and we should know where is our master sheet. Okay, data sheet, where is? So I know. So click here, browse. Okay, click browse. This browse will open. So I know that it is on desktop. Okay, on desktop I have saved that file in Stata Workshop folder. So when I click this, okay, this will open, and this is my practice data sheet final 2. This is. So what I have to do, I have to click this. When I click this, you can see here in file name, there is a changes. Okay. When I click this will come here. Then click open. When we click this open, you can see here, this is a data sheet. Okay, imported into our Jamovi software. You can see here. Okay, this is, we can check, you can like, okay, how many patients, whatever you want to do, you can check here. There's a total 200. You can check. This is around 200. Okay, yeah, it's around 200. We can check, okay, according to. Then first, what we have to do, okay, we have to check, for example, what I have to do, I have to calculate for first categorical variable. Okay, and for categorical variable, what I have to do, I have to calculate how many male and how many females. So one is male and two is female. You can see here, male 1, 2 female. So what I have to do, I have to click this exploration. You can see left upper corner, exploration. Okay, then you have to click this exploration. This dialog box will come, you can see, and this is, you have to click descriptives. Exploration, then descriptive. Click descriptive. When you click, this window will come. Okay, you can see here. You will get here or you will get here. It's okay. There is no problem. I got in right side of the screen. You will get in left side. So there is no problem. Then what you have to do? You have to click, because I want to know how many male and how many female. Then what I have to do? I have to click sex code here. And then I have to bring this sex code into this variable box. So what I have to do? I have to click this horizontal arrow, right side horizontal arrow. I have to click. So this sex code will be, okay, this came here, transferred here. You can see. Then what you have to do? You can see here. And then statistics here, you can see we need a frequency table. So this is frequency table, you can see. You just click frequency table. This will automatically come. Okay. So 1 is male, 2 is female. How many male? 72. This is a percentage. How many female? 128. This is a percentage. Frequency and percentage we can get. If I want a table, so graph, then I have to click this plots, and then I need bar plot, then I can click on bar plot. You can get this bar plot. Okay. It will take time, but you will get definitely. There is no problem. When you like do, this is bar plot you can get. Okay, this is Jamovi. This is a descriptive statistics. Okay. Now you can do for frequency and percentage. You can do for diabetes also. You can bring diabetes from here to here. You can do for smoking. Okay. But frequency and percentage you can do for occupation. You can bring, okay, together. You can bring group also, how many in intervention group, how many in control group. There is no problem. You can get frequency and percentage for categorical and qualitative variable. But for age, income, height, weight, history of like family history of diabetes, you can bring this here also. You will get. So whatever you will bring here, you will get automatically result here. You will get graphs here, okay? And these are the, for categorical variable, no need of this mean, median, standard deviation, minimum, and maximum. There is no need of this. For categorical or qualitative variable. For categorical and qualitative, we need these frequency table. How many smokers? One is smoking, zero is not smoking. So out of 200, 104 were smoker, around 52%. Okay, so we can get this. Okay, then I want to, if I want to save this, so what I have to do, I have to right click here, then this will come all, then copy. We can export, we can do copy, then copy, and then here I can, like here, okay, then I new, and in new there is Microsoft Word. If I click Microsoft Word, this is a result. Then in result, if I want to save, then I can paste here. Then I can paste here. I can get these, and then I can use it for my article, thesis. I can use. Okay, so it's very easy software. Then now, for because as I told you that normal distribution we can check only for quantitative variable, continuous variable, not for categorical or qualitative variable. Okay, you should remember this. Now I can bring back all these variable here, and this is for descriptive statistics for categorical or qualitative type of variable. Okay, for quantitative type of variable, we can do mean, median, standard deviation, minimum, maximum, interquartile range, and normalcy. Okay, we can do histogram. So which is quantitative variable? Age is quantitative variable, for example. Then I can bring age from here to here. Then in statistics, I can see here, this is a statistic, you can see statistics plot. Then I can click here statistics, you will get this. Already it is like mean, median, okay? There is a percentile, you can click, just click. Then skewness, then kurtosis, then IQR you can get, okay? Then Shapiro will test, then standard error of mean, then confidence interval for mean. In plot, you will get histogram, box plot, whatever you want, you can get Weiland plot, QQ plot, you can get anything. And then you can see here, okay? Mean of age is, you can see here in descriptive statistics, right side, mean is 26.4 and standard deviation is 7.52. This is 95% confidence interval of mean you can get, 25.4, 27.5. This is median, 27.0. This is IQR 11. This is minimum. This is maximum. This is skewness. This is kurtosis. So skewness is close to 0. You can see here, minus 0.089. Close to 0. It means we can say age is normally distributed. Also, kurtosis is close to 0. Okay, you can see. Then this is a Shapiro-Wilk p-value. Shapiro-Wilk p. You can see here. P means p-value. And this is Shapiro-Wilk W means test value. But we need p-value. And this p-value is 0.616. It is greater than or less than 0.05. It is greater than 0.05. Okay, so we can say the age is normally distributed. If we got p-value less than 0.05, then we can say it is not normally distributed. Everything is in descriptive table. Then this is 50% percentile is your median. 50th percentile is median. 27 you can see. Here median you can see. Okay. Here median you can see. Median here see 27.0 you can see here median. And here 50th percentile is equal to median. So this is 25 percentile is a first quartile And 75th percentile, you can see in this descriptive table, is also is a third quartile. So from first quartile to third quartile, Q1 and this is Q3. 50th percentile is a second quartile, that is a Q2. So Q1 to Q3, that is a interquartile range. So what is interquartile range? 21.02 TO2, 32.0. And what is median? 27.0. We can present our data according to this. Okay. Then what we want to see? This is frequency table. We don't need this frequency table for mainly for quantitative type of data. Then I can declick this frequency table. You can see, declick this. It will automatically gone. There is no problem. Then there is other, okay. This is QQ plot. You can see this is QQ plot. Okay, then I can see this QQ plot. This straight line is normally distributed, and most of the observation, these black dot are the observations, age observation on the this straight line or normally distributed line. So it means age is a normally distributed. You can see this is a violin plot, okay, with this box and whisker plot. This is box and whisker, and this is a distribution of the data violin plot. You can see here box and whisker plot. In box and whisker plot, this is box, you can see, and these line are whiskers. Okay, so this dark horizontal line between this box, within this box, it is called median. And this is this box like below line, this is first quartile, and this is third quartile. You can see. Okay, so you can see according to this, and this is a, you can see like histogram. So it is looking normally distributed. Shapiro we have done, and if I want to like check any outlier, then I just click on outlier. We can get, there is no problem. Outlier most extreme I can get, just click, then you can see if you want to see. But for me, age is a normally distributed. Then what I should use? Mean or SD and median IQR. We should go for mean and SD, standard deviation. And if I want to give 95% percentage of this confidence interval of this mean, then I can write down this 25.4 to 27.5. Okay, so this is, I think, all about descriptive statistics generally we are using. So if you have any question, you can ask me. You can do for other also, like income, height, you can put all the thing, weight, you can put PAN score along like pre-systolic, post, anxiety pre, anxiety post, then you can get all the things here. It is coming, all the coming, okay? So there is no problem. You will get all the things for this. This is income, this is for, okay? You can see here, descriptive. This is QQ plot. You can see it is not normally distributed. These are the outliers here. Okay, you can see these are the outliers. Okay, so you can see here. This is for all. This is also outliers here. Okay, so you have to see for which variable. This is for height. Height is not normally distributed. Then this is for weight. Weight is also not normally distributed. Using this QQ plot, we can see this is PAN score is not normally distributed. So this is like, and this is like box and whisker plot. This is a histogram. So we can see using this and this, and this is all about this descriptive statistics we can get here. Okay, so like height, all the things for age, income, height, weight, PAN score, and we can use this. So this is all about descriptive statistics. If you have any question, you can ask. Okay, thank you. So I'm stop sharing my slide.
Thank you, sir. It is a wonderful session. I think some query about the chat box.
So I
Can
think,
you,
yes, ma'am.
sir, I think someone asked about the zombie software. Ask
Yeah.
about the zombie software free or lifetime or 1 month.
No, no,
What
it's
the
right now it's free for lifetime. In future, I
oh,
cannot say.
oh,
Today, it's
okay.
free for lifetime. So if you have any like question, any participant, they can ask. There is no problem. But when we do this Jamovi, it's very like easy. You can see here, it's very easy software. So just enter data, like import data, and then you can perform. Tomorrow we will do inferential statistics. Then we will use t-test and chi-square test, one-way ANOVA test, something like that. Okay.
Yes, sir. Thank you so much. We get
Yes.
some. Thank
I
you, sir.
hope the candidates got to know about the Jamovi software today. Previously, SPSS was also free, but now it is chargeable after 1 month trial. So same
Yes,
like
ma'am.
currently it's free.
It's free. Currently, it's free.
Yes, and it is much lighter than SPSS as well.
Okay.
Handy to use for the beginners.
Yes, yes, yes.
One more, I think, query is there. How to mention value in Jamovi, like 1 is equal to male, 2 for female. I think they are asking about coding.
Coding. So there is no problem. I think I have to share again. Then I can show you how to code here. Okay. So here you can see that that is a male and female. So first here is like you can see here. This is female, you have given code 2. This is male, you have given code 1. So first there is no need of coding. But if you want to do coding, then what you have to do, you have to go for variable. You can see here variable. Okay. Here. Then you have to click this variable. Then what you have to do, this is okay, sex code is already checked here. You can see. Then what you have to do, you have to click edit. Okay, edit option. So when you click this edit option, this will come. Okay. So what you have to do, this is analysis. You can see here, this is analysis. Okay. In analysis, in variable, you have to click variable, then you will get this. Okay. In variable, you have to click edit, then edit this sex code, then you can give coding here. Here, 1 is equal to M and 2 is equal to female. Okay, then you will get this over there. Then when I see my data, then you can see here. Okay, 2 is equal to female, 1 is equal to male. This will come here. In SPSS, it will not coming according to this, but there is some software differences and we have to adopt it. There is no problem. Then we can give coding according to this. Okay. So what you have to do, we have to click variable, in variable, then edit. We have to select that variable, particular variable. For example, diabetes. If I want to give diabetes, I have to click here and then I have to click edit. This diabetes came here. Then I can give 0 is equal to no and 1 is equal to yes. Then it's okay. There is no problem. Okay. Then I can see my data and I can see diabetes. This is diabetes. Yes and no. And now we will perform any test, then it will come no and yes format. 0 is equal to no, 1 is equal to yes format. Okay. So if you have any question, you can ask There's no problem.
There's some queries also there. First is that can we get any module on how to use zombie software?
Yes, you can get YouTube YouTube modules. It's free of cost.
Okay.
There is no problem.
One more question is there also, sir. Which software is more friendly, zombie or SPSS?
Okay, if you ask me that, I say it's my answer is SPSS, but SPSS is not free. Jamovi is it's free, and it's we can get attractive for example, like some for example, I don't know about latest version. Okay, I don't know about latest version. I have 25 version of SPSS, but and in 25 SPSS I cannot get effect size. I don't know about 30 version. We can get also in 30 version. I don't know, but it is paid software. Okay, and in Jamovi software, we can get effect size also, con D, something like that. And it's 95% confidence interval. And nowadays, research papers or journals want this con D something in 95% confidence interval with the beautiful graphs. But SPSS is for me, it's a friendly because I'm using SPSS since 2012. I'm using, so it's friendly for me. But if someone is using Jamovi for this much long period duration, then I think for that Jamovi is also user friendly for them. Okay, can you
Sir,
give
one query is
like a data 1 to 5? Okay. So 1 to 5, that's I think for okay, 1 to 5. So there is a variable, for example, occupation. It is given 1 to 4 category. You can remember, you can think about that. It is not a occupation. It is a some like a data 1 to 5. So then you can get like frequency and percentage and graph. You can get. Okay, because Leica data, it has like one scale, so there is a also total score is I think should be over there, total score. So for total score you can get mean, median, frequency, something like that. This is a Leica data, Leica scale data. Then you can enter in Excel sheet, then you can import in Jamovi. You can directly enter data in Jamovi also, but I recommend please enter in Excel sheet, then you can import in Excel or SPSS or R, whatever software you have. Okay, so I think you got my point. Yes, if you have any any participant, any question, there you can ask.
actually one query is also there, sir.
Yeah,
Can you give an example for Likert scale data 1 to 5?
yeah, I have I think answered this question.
Yeah.
Yeah.
So I hope the most queries were about the which software they should use, which is most beginner friendly. Everyone
Okay.
just
For
wanted to know.
beginner,
I
yeah,
think
you can
the
use
beginners they
Jamovi.
can go. Yeah, Jamovi is best for them actually
Jamovi is
because
very easy.
SPSS needs more concentration, more expertise.
Hmm. But if you want to learn space, you can learn. There is no
Yeah.
problem.
Yes, sir. And on YouTube, I think many of the videos are available, how to import data,
Yes.
how to do the coding, because for the beginners, they must learn about the coding first, how to code their variables. And like, sir, you have explained very nicely that how to categorize the data, complete data,
Yes.
descriptive data, continuous it is, which test we should go for. So thank you very much, Dr. Ashok, sir,
Thank
for
you, man.
this
Thank you.
hands-on experience, for this descriptive start. And thank you for
Thank you.
accepting our invitation. You're so humble, sir. Thank you so much from the bottom of my heart and from the whole team of NTI.
Thank you, ma'am. Thank you. It's my pleasure,
Uh,
ma'am. Thank you.
Same here, sir. So, dear participants, I think the session was very fruitful to all of us. See you tomorrow for the inferential start on the same time. Join on 3 p.m. Thank you, everyone.